Hi everyone, welcome to Study with Akshay and this is Akshay. In this video, we are going to continue with the numerical problems given in the exercise. So, in the previous video, we had stopped till 12th numericals. In this video, we will be starting with the 13th numerical. So, before getting started, if you have not subscribed to my channel, please do subscribe and hit on the bell icon to get regular notification. Let's not waste time, let's get started. So we have a 13th question like this. A physical balance has its arms of length 60 centimeter and 40 centimeter. What weight kept at kept on a pan of longer arm will balance an object of weight 100 gram force, GF means gram force, kept on the other pan. So yes. Next one. Let's see the solution. From the principle of moments. Okay, what is the principle of moments, children? Anti-clockwise moments is equal to clockwise moments. Right, this is nothing but the principle of moments. Next. So as per that, we have it as 100 gram force into 40 centimeter equals W into 60 centimeter. So what is 100 GF? It is with the anti-clockwise moment side. 100 into 40 equals W into 60. So how to find W now? Simple mathematics calculation, right? W is equal to 100 into 40 by 60, that is 200 by 3, that is 66.67 gram force. So this is nothing but our weight which is kept on the other pan, right? Longer pan. The weight kept on the longer pan will be 66.67 gram force. Okay, let's move ahead further. So this is a different kind of problem. We all know what kind of problem is this. This is a meter rule problem, right? So the diagram shows a uniform meter rule weight 100 GF pivoted at a center O. The weight of 150 GF and 250 GF hang from point A and B respectively of the meter rule such that OA is 40 centimeter and OB is 20 centimeter. Calculate. First one, total anti-clockwise moment about O. Second one, the total clockwise moment about O. Third one, the difference of anti-clockwise and clockwise moments. Fourth one, the distance from O where 100 GF weight should be placed to balance the meter rule. So this is a diagram. Hope you all can see the diagram, right? Next one. Total anti-clockwise movement about O. So what will be the total anti-clockwise movement? 150 GF into 40 equals 6000 GF centimeter. Right. Next one. Total clockwise moments. So this is our basically second question, right? Total clockwise moment about O. That will be 250 GF into 20, that is this part. 250 into 20, that is 5000 gram centimeter. Next, the difference of anti-clockwise and clockwise movement, 6000 minus 5000, that is 10,000 GF. Okay, it is understood. From the principle of moment, so this will be the fourth question. The distance from O where 100 GF weight should be placed to balance the meter rule. So basically we are supposed to find the distance, right? Anti-clockwise moment is equal to clockwise moment. Then to balance it, 100 GF weight should be kept on the right hand side uh, so as to produce a clockwise moment about O. Let the distance from O be d centimeter. Right hand side, let the distance be d centimeter. Then 150 GF into 40 equals 250 GF into 20 plus 100 GF into D. So again, we use the same procedure. There is nothing is different. 6000 GF equals 5000 GF plus 1000 GF into D. Next, 1000 GF is equal to 100 GF into T. Sorry, I just mispronounced it as 1000 GF. It is 100 GF into T. Okay, so now D we will keep it this side. This one we will bring over here so that we will have 10 GF, 10 centimeter. I'm sorry, 10 centimeter will be on the right hand side of the O. Okay, at that place where 10 centimeter here we should place our 100 GF weight. Right. Let's move with the next question. A uniform meter rule weight 10 GF is pivoted at its O mark, basically O mark. First question, what moment of force depresses the rule? How can it be made horizontally by applying a least force? So anti-clockwise movement, 10 GF into 50 centimeter equals 500 GF centimeter. From the principle of moments, anti-clockwise moments is equal to clockwise moments. 1001 times we have told us, right? So again the same equation, we will equate them, we'll get W as 5GF. There is no confusion, right? Least force will be 5GF. Okay, I'm sorry. By applying a force of 5GF upwards at 100 centimeter mark, rule can be made horizontal, right? So that's what even I told, right? That's it. Next question we have it, 16th one. A uniform half meter rule can be balanced at 29.0 centimeter mark, where a mass of 20 gram is hung from its one end. First one, A question we have. Draw a diagram of the arrangement. Find the mass of half meter rule. In what direction would the balance point shift if 20 gram mass is shifted inside from its one end? So yeah, basically everything matters with respect to the diagram. If you draw the diagram properly, the complete rest of the two questions might come properly. Right. This is the diagram basically. We are done with the first question. Next one. So that's it. This is basically an explanation of it. You can pause the video and read across it, or else I will only read. Figure shows a uniform half meter rule PQ, which is balanced at 29 centimeter mark. Let M be the mass of the rule. A uniform a uniform rule has some distributions of mass throughout its length. So its weight mg will act at its middle point, which is at 25 centimeter. 25 centimeter is the point where the weight acts. The weight mg produces anti-clockwise moment about point O in order to balance 20 grams or 0.02 kg. Gram must be converted into kg. Weight is tied at 50 centimeter mark, which generates clockwise moments. Right. Next, hence from the principle of moments, anti-clockwise moments is equal to clockwise moments. So we have the weights given as mg and 0.02. Basically, this is kg, not g, it is just kg. Okay, this is mass in grams ಅಂತ ತಗೊಂಡ್ರೆ 20 grams ಅಂತಾನೆ ತಗೊಳ್ಬೇಕಿಲ್ಲಿ. Sorry, it's a printing mistake basically. It's basically a printing mistake. That's it. M is equal to 21 of 0.2 divided by 4. M is equal to 0.105 kg. Right. So this is a B question. Let's see with the C question. Kg lineado, so we have to convert them into gram. Since it is in kg, we have to convert it into grams. So it is converted into grams because in the question they have given in grams. We cannot keep it as kgs. In order to apply anti-clockwise and clockwise movements, that is principle of movements, we are converting it into kg. That's it. So towards 25 centimeter mark, this acts. So that is basically the direction with respect to that question. That is a C question. Okay, this was basically a C question. 17th question. A uniform meter rule of mass 100 gram is balanced on a fulcrum at a mark 40 centimeter by suspending an unknown mass m at a mark 20 centimeter. Find the value of m to which side the meter rule will tilt if the mass m is moved to the mark 10. What is the resultant moment now? How can it be balanced by another mass 50 grams? From the principle of moment. Please do adjust. The font size is small. Clockwise is equal to anti-clockwise, so and so, so and so, so and so. So we get m as 50 grams by using the principle of moments. And then the meter rule will tilt on the side of mass anti-clockwise movement since m is moved 10 centimeter. Okay, which side they have asked? So we have told anti-clockwise side. That's it. Next, third question. What is the resultant moment? Anti-clockwise moment m is moved to mark 10. So 50 grams into so and so, we get 1500 grams. So clockwise movement will be 1000 gram. That this was anti-clockwise movement basically. So this is clockwise movement. Next, resultant moment will be anti-clockwise minus clockwise. That will be 500 grams centimeter, which will be in anti-clockwise direction. So resultant direction will be anti-clockwise. Next, first question. How can it be balanced, Allah? So from the principle of moments, we have clockwise moments is equal to anti-clockwise moments. So to balance it, 50-gram weight should be kept on the right side so as to produce a clockwise moment. Let its distance from fulcrum be d centimeter. Here they have not asked the diagram, so please don't draw the diagram and waste your time. So just answer to the question. Since we have 4 sub questions, it will be given 4 marks. Each question 1 mark. But please don't skip the steps. 100 gram is equal to 50 minus 40 plus 50 gram into d equals 50 gram into 40 minus 10 centimeter. So we get d as 10 centimeter. So it can be balanced at 10 centimeter mark. That's so here we have 1, 2, 3 and fourth question. By suspending a mass of 50 gram at mark 50 centimeter, it can be balanced. Henceforth, we are done with 17th question. Let's move ahead further with the 18th question. And this is the last question from exercise 1A, right? And this is the last numerical from exercise 1A. In figure below, a uniform bar of length 1 meter is supported at its ends and loaded with a weight WKGF. KGF is not a movie, it's kilogram fourth at its middle. In equilibrium, find the relation or reaction. Find the reaction R1 and R2 at the end. They have only given the int, right? With the help of the int, we can solve this. So here you get the solution, complete solution has been displayed. So they have only given the diagram, they have only given the hint. In your exam diagram they might give, but int will never be given. So please don't depend upon int. Since they have given in this question, I have used the hint and I have solved, else you must be knowing the method of solving. I hope so. I have taught you how to solve this, or else while we are solving the example numericals, it will be more and more clear, I suppose. Right. According to principle of moment, clockwise equals anti-clockwise, right? R1 plus R2 is equal to W. As the system is in equilibrium, R1 into 1 by 2 equals R2 into 1 by 2. This they have only given as per the int. So I will take a pen and write over here as per the hint. Right. So I'm sorry, just a minute. As per the int, this is. So R1 equals R2. 2R1 is equal to W. Then R1 equals R2, that is W by 2. So since according to this step is brought over here. Okay. I'll just take it over here. This step we are considering over here and we are solving it. Hope you have understood this question. Okay. So please make a note of it. And the concepts are clear, I suppose. So let's meet with the next video with a next exercise one. Sorry, not with exercise 1B. We will be solving example numericals in the next video. Basically, we will be solving example numericals in the next video since we have skipped it. So we will be getting it in the next video. So before ending this video, if you have liked, please click on the thumbs up button, share this video, you can comment, you can post your doubts in the comment window as well as using the mail ID studywithakshay65 at gmail.com. I will try to clear your doubt as fast as possible. So please do wear mask, follow social distancing, sanitize at regular intervals. May please do follow COVID appropriate behavior. Together, let's all fight against that COVID-19 coronavirus. Thank you. Stay home, stay safe.